it is given to you that chord AB of a circle. What do you mean by chord of a circle? I think we discussed this last year in class 8. What do you mean by chord of a circle?
Hello. Good morning, sir.
Good morning. If you have a circle and you have a straight line, from one point you take on a circle and you draw a straight line to the other part of the circle, to another point on the circle. In fact, you join any 2 points on the circle. If you join any 2 points on the circle, this line segment that we get, AB, this is called the chord of a circle. Okay, so here it is given to you that chord AB of a circle of radius 10 centimeters. So let us say that this is the center of the circle and the radius of this is 10 centimeters. And this is given to you as a right angled triangle that is formed. Okay. The question here is find the area of the sector OACB and any point C they have called here. C is any point on this arc. Okay. Question is find the area of the sector OACB. What do you mean by area of the sector? What is the sector of a circle? If you have a circle, this is your center. Okay. And these two are the, suppose this is your center, this is the center of the circle. These two are the radii, OA and OB. Then these two are the sectors of the circle. This is called a sector of a circle. Okay. This is another sector. This is called the sector of the red shaded part is called the sector of a circle. Okay. So the question here is how to find out the area of this sector OACB. So what does this sector look like? Can you tell me what this sector looks like?
Triangle.
Triangle. No. This sector actually looks like a quadrant this way. This sector looks like this. Do you agree or not?
Yes, sir.
Yes. And the radius of this is
Yes.
10 centimeters. Okay. So this, you need to find out the area of this sector. Okay. So what should be the area of this sector? What is area of a quadrant? 1/4 of pi r square, right? So area of sector OACB is 1/4 pi r square, right? Because this is 90 degree, it will divide the circle into 4 parts, right? Entire circle is 360 degree and 90 degree means 1/4. Okay, 1/4 of pi r square. So 1/4. Now you can put the value of pi here. Okay. Or you can put it later on also. 1/4 into pi into r square is 10, 10 square. So this is 100 pi by 4, which is 25 pi. Okay, we'll put the value of pi later. Okay, 25 pi. If not, if the 2.3 it is given, take pi is equal to 3.14. You can put it here, 25 into 3.14, because they have asked you specifically for this area. So you get 78.5 centimeters square. The first part was fairly easy, area of the sector. The next part is the main part, that is how to find out the area of the major segment. Now, what do you mean by segment of a circle?
So the two parts which were divided when a chord is drawn.
Again,
That's divided drawn.
Divided by what?
Divided by a chord.
Yes. If you have a circle and if you have a chord of a circle, this chord divides the circle into two parts. This part, okay, and you have this part. Okay, this is called this is a smaller part of the circle. Okay, this is a smaller part of the circle, therefore it is called the minor segment. And this is the bigger part, so this is called the
Major.
major segment. Okay, so the question here is find the area of the major segment of this circle. So what is the major segment here? The major segment here is this.
That red line.
This shaded part is the major segment. But the question is how to find out the area of this major segment. See that area of this major segment is area of the entire circle minus area of this minor segment that I shade in green, right? But the problem is how to find out the area of the green part, that is the minor segment. So let us first find out the area of the minor segment. Now what is the area of the minor segment? If you see, the area of the minor segment is area of the sector that we have found out here, this entire sector, this sector that we have found out here, 25 pi or 78.5. This is the area of this minus the area of this triangle here, right? So this will give you the area of this part, right? So we find out the area of the minor segment first. So area of the minor segment is equal to area of the sector OACB minus area of the triangle OAB. Okay, now area, what is the area of this sector? We have already found out 78.5 minus, and what is the area of the triangle? If you see this triangle here, this triangle, so the right angle triangle, right? So half base into height. And what is the base? 10 centimeters. And what is the height? 10 centimeters. So half base into height. So this will be 78.5 minus 50. Give you 28.5 centimeters square. Okay, the area of this is the minor segment. So therefore, what should be the area of the major segment? The part that is shaded in red here. Area of major segment is equal to area of the circle minus area of the minor segment. Okay, area of the circle is pi r square. Radius is 10, so pi r square minus area of the minor segment. We have already found this out to be 28.5. So that is done. So this is 100 pi minus 28.5. Now you can put the value of pi, 3.14 minus 28.5. So this is 314 minus 28.5, which comes out to be 285.5 centimeter square. In fact, 285.5 centimeters square. That is what. Okay. Let us move on to the next problem. The question states here that a sheet, a rectangular sheet in fact, 11 centimeters long and 2 centimeter wide. Okay, so you have a rectangular sheet, 11 centimeters in length and 2 centimeter in width. Okay, is cut to prepare discs. Calculate the number of discs that can be prepared. Now these are circular discs. Okay, circular disc 0.5 centimeter in diameter. So what happens is that you cut out circular disc from this in this manner. Okay, you keep cutting lengthwise and you keep cutting breadthwise also. So how many discs can you prepare from this? And the diameter of each of these discs is 0.5 centimeter. Now, if you remember one problem I think I did in the beginning, I told you that a circle of greatest area that can be cut out of a rectangle is possible only if it is a square. If you remember, in fact, I have not exactly discussed this problem, but what I just told you is that if you have a square, then only I can cut out a circle from this, which is of the greatest diameter. This I mentioned, I think. Who asked the question? Vishnu, I think, asked this question. And I think I said that a circle of greatest area that can be cut out from a rectangular piece is only possible if this rectangular piece is a square. Okay, so that means this is the diameter, 0.5 centimeters. That means the side of this square must be 0.5 centimeters. Okay, so that means what you do here is, in order to cut out circle lengthwise, you have to cut out a square first of side 0.5. So lengthwise, how many squares can you cut? Number of squares
So
that can be cut out of the rectangular sheet lengthwise. How many can you cut lengthwise? What is the length here given? Length is given to be 11 centimeters. And if you're cutting out a square of side 0.5, how many squares can you cut out? 11 divided by 0.5? Do you agree or not?
22. Yes, sir.
Yes.
If the length is 11 and if you're cutting out squares like this, then how many squares can you cut out? 11 divided by 0.5. This comes out to be
22.
22 squares you can cut out lengthwise. Similarly, how many squares can you cut out breadthwise? Number of squares that can be cut out breadthwise. Similarly, what is the breadth here? Breadth here is 2
2.
centimeters. So 2, and each side, a square is of side 0.5. So now how many squares can be cut out breadthwise? 2 divided by 0.5. So that is 20 divided by 5. You can only cut out 4 squares breadthwise. So if you are cutting 22 squares here lengthwise, and breadthwise, if you're only cutting 4 squares, how many squares are actually cutting out? 22 into 4. Therefore, number of squares that can be cut out
88.
is 22 into 4. It's 22 into 4, which is 88. So therefore, number of circles that can be cut out is also is also 88. Okay, so this was more of a common sense problem than a mensuration problem. Next problem is the wheel of a cart. Now here you have to understand this problem a little bit. This is also a little bit of uh, common sense here. The wheel of a cart is there, which makes 5 revolutions in 1 second. Okay, so in 1 second, suppose this is your wheel here. Okay, and say it is on this on this this is the floor on which it is rotating. Okay, and what happens is that this reaches this point here. The wheel of a cart say reaches this point here after 1 second. Okay, so in 1 second, this wheel moves from this point to this point. Okay, now see here, this consider this point that is in contact with the ground. Okay, consider this point that is in contact with the ground. Let us say this point is X. Okay, now what happens? This wheel is rotating, say in this manner. Okay, and say after one complete revolution, it again this point X comes back here. Then can you tell me what should be this distance? What should be this distance? Can you tell me what should be this distance? If I have started from point here and I'm rotating along this wheel, okay, suppose I'm walking along this circle, okay, and this wheel is not walking, let's say this wheel is rotating, okay, this wheel is rotating, and this point, it comes back after rotating one complete circle, this point is back here, then what is this distance that I have covered? Then what is this distance that I have covered? This distance, if you see, if you think very carefully, this distance that I have covered is equal to the circumference of the wheel. Do you agree or not? Do you agree or not?
So the distance is equals to circumference of the wheel.
Exactly. This x dashed, not x, this distance here, is it equal to the circumference of the wheel? The wheel is rotating. Okay. Consider any point on the wheel here on the circumference. If this wheel is rotating and it travels this distance, okay, it travels this distance from x to this distance, okay, and it is coming back such that this point is coming back to its original point that it was here, then can I say it has covered the entire circumference of the circle and come back to this point? Obviously, if x has to reach the same point after some time, it has to cover the entire circumference, isn't it?
Yes, sir.
If I am
Sir,
starting, if I am, yes,
sir, can it be the perimeter of the path from which the circle is traveling?
perimeter of the path,
From where
peri-
the circle is
there's nothing called perimeter of the
traveling?
path. Perimeter is nothing but the perimeter is the boundary. Uh, Path is not related to perimeter, but if you can put it in better words, maybe I can understand. What do you mean? Yes, Neha, tell me.
Sir, don't know.
See the if I consider this point here, suppose the wheel reaches here. Suppose the wheel reaches here. Okay. Then say X is say here. What is this distance covered? What is this? Not this distance, but in fact this distance. What is this distance covered here? What is this distance covered? This distance is covered must be equal to this length of this arc. Do you agree? And then finally, when it completes rotation, one complete rotation, and it comes back here to this point, then it covers an entire length of the circumference. It covers this entire length. Only then can it come back to the same point. If I consider any point on the circumference of the wheel, then for that point to come to the same point after one complete rotation, it has to cover the entire circumference of the circle. Only then can it come back to the same point. Otherwise, it will not come back to the same point in one revolution. Okay, so in one complete revolution, it is coming back. Just for example, let's say as the Earth is rotating, okay, it starts from it is revolving around the sun. Now, if the Earth starts from one point, and if it has to come back to the same point, it has to cover an entire what? It has to cover an entire circular rotation, revolution, in fact. So we apply exactly the same concept, that if I start from a particular point, and if I want to come back to the same point after one revolution, what is the distance that I have covered? I have covered one complete revolution. So if this wheel has a point here, and if it comes back to this point, same point here, then it obviously has traveled an entire circumference. It has traveled an entire circumference to come back to the same point. So therefore, what can I say? That in 1 second, what is the distance covered? Distance covered in 1 second is equal to circumference of the wheel. Right? So let us calculate
Yes,
the
sir.
circumference of the wheel. Circumference of the wheel here is, what is the radius given? Diameter is given. The diameter of this wheel is 84. Okay, so the radius is 42, half of the diameter, is equal to 2 pi r, 2 pi into 42, which comes out to be 84 pi centimeters. This is the distance covered in 1 second, in one revolution. Now, how many? Okay, it is making 5 revolutions in 1 second. So this is not the distance covered in 1 second. Distance covered in one revolution. Distance covered in one revolution. It is making 5 revolutions in 1 second. So therefore, distance covered in 5 revolutions is how many? 5 into 84 pi. Okay, which comes out to be, you can put the value of pi here. 84 is a multiple of 7, so you can put it. So this comes out to be 1320 centimeters. Okay. This is the distance covered in how much time? It is making 5 revolutions in 1 second.
Okay.
It is making 5 revolutions in 1 second. And what is the distance covered in 5 revolutions? You have calculated this to be 1320. So therefore, 1320 centimeters is covered in 1 second. So what is the speed? You can say, what is the speed here? What is the speed of the wheel? Find speed in kilometer per hour. Okay. So what is the speed here? 1320 centimeter per second, right? This is the speed, but they have asked you to express this in kilometer. So what you do is you just convert this centimeter to kilometer. So 1320 centimeter is 1320 divided by 100 meters, which is 13.2 meters. And when meter is converted to kilometer, it is 13.2 divided by 1000 kilometer, which is 0.0132 kilometer. So what is the speed therefore? 0.0132 kilometer per second. But we have to express in kilometer per hour. Now this second needs to be converted to hour. So how many seconds is equal to 1 second is equal to how many minutes? 1 by 60 minutes, which is equal to 1 by 60 into 1 by 60 hours. Hour, in fact. Okay, so therefore, when this speed, kilometer per second, now if I convert to hour, second, if I convert to hour, this will be 0.0132. This second, I'm converting to hour. 1 by 60 into 1 by 60. So this is 0.0132 into 60 into 60. So this comes out to be 47.52 kilometer per hour. And which can be to the, if you approximate it to the nearest kilometer, it is 48 kilometer per hour, which is to the nearest kilometer. Okay. So that brings us to an end of this chapter. We start with midpoint theorem. Now midpoint theorem basics I just want to mention here first. I won't be able to cover much. Okay. Now in midpoint theorem, you go through the statement of the midpoint theorem, but main thing here is what you must see what is given to you and what you can conclude. Even when we are discussing after midpoint theorem, I'll be discussing the converse of midpoint theorem. The only difference will be what is given and what you can conclude. So see here, in midpoint theorem, a triangle is given to you with two midpoints of sides. Suppose ABC is a triangle and the midpoints of AB is P. What do you mean by midpoint? Midpoint is a point such that AP is equal to PB. Okay. And another midpoint is given here, say Q. It's such that AQ is equal to QC. Two midpoints are given to you. Now what you do is you join these two midpoints. Okay, so what is given to you here? This is your midpoint theorem. Okay, given here is triangle ABC, any triangle ABC with P and Q as midpoints of sides AB and AC. Respectively. So, you need to have a very good look at what is given. So you see what is given, triangle ABC is given, P is the midpoint of AB given, Q is the midpoint of AC given. Okay. If these things are given, then what you can conclude from midpoint theorem is that this straight line PQ has to be parallel to BC. That is, this line PQ has to be parallel to this line BC. Only if these things are given. Otherwise, you will not be able to conclude. Only if these things are given, only then you can conclude that PQ is parallel to BC. Not only that, according to midpoint theorem, you can make two conclusions. That PQ is parallel to BC, and the second conclusion that you can make is that the length of PQ must be equal to half of the length of BC. These two are the conclusions that you can make from midpoint theorem. So I repeat once again. Keep an eye on what is given to you. Okay. If a triangle is given to you in which two midpoints are given, P and Q, and such that you join the midpoints, then you can apply midpoint theorem. Okay. And what can you apply? And after applying midpoint theorem, what can you conclude? You can conclude that this line PQ must be parallel to this line BC. Okay. This is what you can conclude. Now, what is BC? BC is the third side. Okay. Suppose if I give you this kind of a triangle. This kind of a triangle in which I give you the, say I call this triangle A, B, C, and I say this is the P, which is the midpoint of AB. And if I give you a midpoint here, Q. Okay. And I join these two also. Then in this case, what can you conclude? Are all the conditions of midpoint being satisfied? Yes, because triangle ABC is given, P is given to be the midpoint, Q is given to be the midpoint. Then what can I conclude here? What can I conclude? That this PQ must be parallel to AC. This is one conclusion that I can make. And the second conclusion that I can make is PQ has to be half of, the length of PQ has to be half of AC. Okay.
Excuse me, sir. So why we write half, like half of AC?
I'm talking about the length here. Suppose if I give you this length to be 24 centimeters, then by midpoint theorem, you can say that this length has to be 12 centimeters. Understood?
Okay, okay. Thank you, sir.
So that is what. Suppose if I give you another one, another triangle, if I give you, and I give you two midpoints here, P. If I give another midpoint here, Q. Okay, this I give you, and join these two. Then what can I conclude here? Can you tell me what can I conclude here? Sonam, can you tell me what can I conclude?
Yes.
Yes, tell me. Are the conditions of midpoint theorem being satisfied here? Yes, tell me fast.
Yes, sir.
Are the conditions satisfied?
Yes, sir.
Yes, sir.
Sir. Yes, sir. It is satisfied.
Okay. Then what can I say?
So PQ parallel
is
to
parallel to
AB
B.
Okay,
AB.
PQ
Yes.
parallel
AB
to AB
and
And
PQ
PQ is half
half
AB.
of AB.
and PQ is half of AB.
AB.
Exactly. The length of PQ is half of the length of AB. So what if I give you the length of PQ as 5 centimeters? Can you find out the length of AB?
And
10 centimeters. So that's the idea of midpoint theorem. Clear? I stop here for today.